Hi everyone, welcome to Java Techie. Microservices have brought a new set of challenges due to their distributed nature. One such challenge is handling cross-cutting concerns such as logging, monitoring, authentication, and many more. So in this tutorial, let's look at how we can use the sidecar pattern to address these challenges within microservices architecture. Okay, alright. So without any further delay, let's get started. So at high level, if you look at this definition, it says that sidecar pattern is about separating cross-cutting operation to a different service from your actual microservice, which helps keep your microservice simpler and less complex. So don't worry if this definition is confusing for you, we'll break it down and understand it in details. Okay, cool. But before we dive into the technical stuff, let's start with a real world example to understand what the sidecar pattern is and why it's needed. As you can see this picture, I have a main vehicle with an attached box, or you can consider it as a sidecar. So while riding the vehicle, I can also use the sidecar to carry extra stuff like grocery or my kid or anything else I need. So here riding the vehicle is my primary task and carrying the things is my secondary task. And how I segregate these two tasks? By just adding a sidecar, which helps me to keep these tasks separate and organized. This is what exactly the sidecar design pattern does. It separates primary task from secondary one by giving each task its own space to focus. Okay? Now that you have a clear picture of what the sidecar pattern is and why it's useful, let's see how it works in real-time microservice architecture. Okay? Imagine I have a couple of microservices like order service, payment service, and dispatch service. Each one needs logging and monitoring, but since these features are so similar, duplicating the code in every microservice doesn't make any sense, right? So instead of mixing these secondary or cross-cutting tasks into every microservice, I want to create a separate service called sidecar to handle these cross-cutting or secondary tasks. This is what we call the sidecar pattern. Simple, right? So what you can do, you create your primary microservice and run it in a container. Similarly, create another service called sidecar to deal with logging and monitoring stuff, and then run it in a different container. So here, if you want, you can also run both the service in a single container, but it's not a good practice to keep them in a single container. Always it's recommended to run these two tasks into different container. Okay, I hope this is clear for you. If yes, then let's check out the architectural diagram for today's example. Okay, basically to demonstrate sidecar pattern, what we are going to do, we'll create two microservices, book service which handle all the business logic and a sidecar service for logging. Okay, currently we'll focus on only one single cross-cutting logic, that is logging, and both the microservice will run on its own container. Now here book service will write the log to a remote file and the sidecar service will read these log and send them to centralized logging system like Elasticsearch or Splunk. It depends on your use case. Finally, we'll use Kubernetes to run both the container in a single pod. Now if you observe here, book service does not care what language your sidecar service is written. It could be in Java or it could be in Python or anything else. This allows for a polyglot approach, making your system more flexible and versatile. really out of the box, isn't it? So just keep a note, this is a simple demo. So I am using the Kubernetes, but in real world scenario with Kubernetes, you might use service mesh like Istio or Linkerd to manage the sidecar pattern more effectively. Okay, all right. I think we have got a good understanding of the sidecar pattern. So let's get started on implementing this scenario in action. So let's go to our IntelliJ idea. But before that, you try to picturize this particular image on your mind because we are going to follow the same step as it is. Okay. So at first step, we'll create two different microservice, book service where we'll write our actual business. Then we'll create a logging service which will act as a sidecar and it will contains all the cross-cutting logic. So first, let's create the book service. To save our time, already I created a simple project or simple microservice called book service. So there is no rocket science. This is the simple application. If you see here in the book service, I am using the hard coded list. In the list, I am adding the book and retrieving all the book from the list. And then this service, I am trying to calling it from the controller class. In controller, I have defined two REST endpoint. One is the add book to the system and second one will retrieve all the book from the system. Okay. And apart from that, if you observe here, I just added the log statement in my microservice. But our goal is to segregate this logic to different service, right? Correct. But here I am just adding the log statement, but I am writing it to the remote file. If you see here, logging.file name, this is the path slash logs and this is what the file name. Okay, this we are going to write in a container layer. So currently this will load, the path will be load from this particular property file. Okay, this is the simple application or you can consider as a simple microservice. So our first part is done. We have successfully created this book service. Now the second part, we need to create a sidecar service or logging service. So let's quickly create this. Now go to the Spring Initializer, then just define all the required field. Then just add the required dependency. Here I am just adding a web dependency. Then just import this particular project to your IntelliJ IDEA. So here is our project. Now what we want to do in this logging service, we just want to read the log file from the container and we want to write it in the sidecar service so that we can integrate to any third party to centralize the logging. It could be Splunk, ELK or Elasticsearch, anything you can directly integrate to your logging sidecar service. Now those things you no need to mix up with book service. Okay, that is what our goal and we are using the sidecar to achieve that. Correct. So let's go to the logging service and let's implement the code to read the log data from the remote location. Okay, so I'll create a service class. Now just annotate this class with @service, then just write a method public void process log who will read the log file from the container and just write it. For now, since this is the demo, I'm not going to integrate any third party like Splunk or anything else. We'll just write it down in the console. Okay, cool. So let me write the logic to read the file. So this is the simple logic, core Java logic to read the file, right? So we are using buffer reader to read the file line by line and see the location. This is where we are writing the log in our container. If you can remember, in the book service, this is what we have defined the path to write all the log data. And in sidecar service, we are reading from the same location. Okay, so let me define it as a constant. Now this particular method will read this particular path and will simply printing the log statement. Okay, so instead of print it, now here you can, since you have the log data with you, you can forward it to Splunk or ELK or Elasticsearch, anywhere you want. It does not matter. Your book service will not impact if you change something else. Let's say today you are using Splunk for centralized logging. Tomorrow you want to use the ELK. Then you no need to touch single code from your microservice. Rather, you can just modify something in your sidecar service. Okay, that is what another advantages of using this sidecar design pattern. Okay, you can achieve the modularity. So for demo purpose, I am just printing the log statement. So we need to tell to this process log method continuously read this particular location or read this particular file and get the log and do your task. Okay, because if you understand here, every second when user access the book service, it will keep write the log to the log file. Now we need to implement some mechanism to pull the log from this file in every second or every minute or based on some scheduler, right? So for that, what you can do in your application, sidecar application, just enable the scheduling by using this particular annotation and just define scheduled and run it on every 1 minute. So every 1 minute this process log will be executed, will read the file from this particular path and it will just print for the demo. Why this is crying? Okay, one additional. Cool, let's close it. So we are done implementing these two services. Now what is the next task? We want to run these two service, book service and the sidecar service in a Docker container. Correct? So for that we need to write a Docker file, then we need to create the Docker image so that we can run it in a container. Correct? So let's start writing the Docker file in each microservice. Let's go to the book service first. Then let me go to the pom.xml. Just define your jar name as a book-service. All good. Let's close everything. Then let me write a file called docker file. Then just define the command of your docker. So we are using the JDK21. Then I want to create the volume where I can mount my logs, and this is what my working directory, and this is what the jar book-service.jar. Just copy that jar to your working directory, which will run on port 8080 in container, and this is the command to execute the jar in container. Okay, so this is the simple docker file. Now similar way, let's create the docker file for our sidecar service, which is logging service. Just create a file, docker file, then just add the command. The command is same, JDK version, and where you want to mount your logs or what will be your temp file storage, and but the port is 8081. Both I cannot run on the same port in a container, right? It will be give the error, port bind exception error. So you need to define the different port, and this is what your jar. Before that, let me verify what I have defined in the pom.xml. So what is the final name? I have not defined anything, right? So just define the, I want my jar name to this log-service. Okay, so we are good now. Now if we'll check the final name in the docker file, it matches, right? Fine. Now if you also observe here, we have defined the expose port as 8081. So your application also should run on this particular port. For that you can go to application.properties file, and here you can define server.port equal to 8081. Also we can do a small modification in our logic. So here if you observe, we have defined the system.out.println, right? So better let's add some log statement so that we can validate this particular class is loading or not, because this is what we are not triggering, right? This will be run on the scheduled manner in every 1 minute. So better let's add the log statement. So for that, let me add the Lombok dependency here, update the project, then just go to the logging service, and then first I will check whether this class is getting initialized or not. So just in the constructor define the log statement. Fine. Then I will also add this log statement to just check when my scheduler started its execution. Okay. Scheduler, also just change here log.info. So let's format it little bit better. Also, if there is any error, instead of throwing it back, you can do log.error. So we are good. Now what we can do, we need to generate the jar file of both the application so that we can create the Docker image. So for that, let's run the maven install. I'll go to the book service. I'll also run here maven install. So you can see here build is succeeded in both the project. Cool. Now what is our next task? We need to create two different Docker images and we need to run them in a Kubernetes container. Okay, this will be one container and this will be another container which you want to run in a Kubernetes pods. Okay, so for that what you can do, let's start the minikube. To start the Kubernetes, just go to the code and let me open the Docker desktop. So once this will be up, then immediately you can open the terminal, and then let me zoom this for you. You can run here minikube start, then it will create a single node Kubernetes cluster for you where you can run your container or where you can create the pod and you can add as many number of container you want to run. So it will take few seconds. Let's wait it to complete. So you can see here Kubernetes is started. To validate that, you can do minikube status. We can see this, right? It's running. Then since our Kubernetes is up and running, let's create the Docker image of our both the project, book service and logging service. So what I'll do, I'll just open a terminal, one for logging service and another one for book service. Then just simply let me minimize this. This will be for logging service and this will be for book service. Now here just create the Docker image for book service. So for that what you can do, first let's check what all images we have. We have couple of images from the Kubernetes. We can see here, right? Now let's create the image Docker build -t, then give the image name. I'll give book -service, then tag you can give anything. I'll give 4.0 root. Okay. Meanwhile, let me also create the image for this logging service. I'll create Docker build -t, then you can give the image name. I'll give sidecar service 4.0. Now if I'll check the Docker images, I can see these two images which we just created, right? Book service and sidecar service, and tag is 4.0. Fine. Now what is the next step? If you understand it correctly, the next step, since we create two different Docker images, we want to run them as a two different container in Kubernetes. But to play with Kubernetes, we need to create the Kubernetes manifest configuration. So basically you need to create the deployment and service object of Kubernetes to run anything in the Kubernetes cluster. So by creating the Kubernetes configuration, deployment configuration, we'll ask Kubernetes, hey Kubernetes, please consider this book service and logging service as two different images and run them in a two different container in a single pod of Kubernetes. Okay, those information we need to tell to the Kubernetes. So for that, let's create the Kubernetes configuration. Let's keep it in a logging service. I'll create a file. I'll name it Kubernetes deployment.yaml. Now let me add the configuration. So it's very simple configuration. The object type is deployment and name of my deployment is this replica 1 because we need a single pod. Okay, this is the selector, and here if you observe the main thing, containers, I need how many containers? 2, book service and sidecar service. These are to my container name. In the book service container, book service docker image will run. This is what the image we just created, and in the sidecar service this particular image will run, and this book service will run on port 8080, where he will write the or mount the log to this particular folder, and this sidecar service will run in port 8081. This is the simple configuration. If you are not aware about how to define deployment object or service object in Kubernetes, I would strongly suggest you to check out my Kubernetes playlist. I will also share the link in video description for your reference. Okay. Now let's quickly create service object. So just define this. This is very simple. Object type is service and name of your service is this, and what are the port 80, what is the container port, what is the host port. We have defined the deployment and service object. Now let's execute these two objects so that things will be run in a Kubernetes. So for that, what I can do, I will open the terminal. Let's say this logging service, clear this. Then here I'll simply apply kubectl apply -f, then deployment is my file, kits-deployment.yml, just execute it. You can see here deployment is created. Let's validate that kubectl get deployments. Okay, now let's check kubectl. Let's check the pods. It should be one pod. We can see a single pod here. Okay, and status is running, there is no error. Now let's apply the service object, kubectl apply -f. So it created the service object as well. To validate that, kubectl get sbc. You can see the service name here, right? Now we are good. So we have the service object and we have the deployment object. Next, you can generate the proxy URL to access your service, but let me do the port forwarding to 8080 to access this particular service which is running on Kubernetes. So kubectl port forward, what is your service name and on which port you want to forward your request. Okay, now what I can do, let me access this particular port. Go to the browser, localhost or 8080. I will open the Swagger documentation of book service. I can hit from the postman, but since I have added the open API, better let's play with the Swagger directly. So these are the two API we are exposing from book service, and we have added a log statement here. So when I will hit this particular request, what it will happen, it will just write the log to this particular location, okay, which is nothing in a container. And next we'll validate the log statement in this sidecar service whether it is able to read the log from this particular location or not. That is what we are going to validate, because we segregate the log statement to sidecar service instead of mixing it up in book service. That is what the simple funda we are following, right? So just go to the browser and let's add couple of book. Try it out. ID 101, title is Java, name or author name James 102, Spring. So we have added two objects. Now let's fetch those two objects. Do the get call. We are getting these two results. Now when I access the book service, I am already adding the log to the file, right? So let's check the container or what I can say. Let's check the log of pod. Then we'll understand whether the things are getting flow from book service to log file and from log file to sidecar or not. Okay. So what I can do, what is the pod name? This one. Just copy the pod name. Let me open the another terminal, book service. Let me check the log, kubectl logs and give the pod name. Now if you'll execute, let's see what is the log we can see here. If you read it carefully, this particular pod, the pod name what we have defined here, having two container, book-service and sidecar-service. That is what we want to achieve. That is correct. But the defaulted container is book service. So if you will specify the pod name directly to check the log, it will show you the log of default service, which is nothing our book service. And you can see the statement in book service, right? These are the log statement: 2 for add request or post request, 1 for get book request. Now we want to validate these things have been logged into the file or not. If it is logged into the file, then whether this statement is processed by my sidecar or not. Okay, that is what we want to achieve. So for that, first let me check whether the log is getting added to the file or not. Let me copy this. Just check. Let me clear this. kubectl execute integrated terminal. This is your pod name. Okay. Then give the path. We can see the log, right? The log is getting added to this particular path. Now let's check the log of sidecar container. So what I'll do, I'll just define which container log I want to watch. That is sidecar service. Okay. So just specify the container name. If you have a pod and it contains multiple container, then you can specify which container log you want to watch. Just enter it. You can see the log statement here. Read it carefully. The log is from the logging service, which is our sidecar. And what is that log? He got the log from book service. What is that log? Add book request to add book request, because that is what we have done, and get book request 1. And if you see here, so just check the log statement we have added here in the logging service scheduler triggered, right? We just want to validate whether our schedule method is running on every 1 minute or not. Okay, so go here and just do if it ran at time C, then it's keep running, right? But we see our result. So what we understand from this flow? It's simple, that this book service write the log to a remote location which is there in a container in Kubernetes, and then the sidecar service read those logs and we are getting the output in console. Since this is just a demo, we are writing it in a console, but you have option to integrate it to the any third party to centralize your logging. So similar way, you can also add your monitoring related stuff. You can add the observability and Prometheus, Grafana, any kind of monitoring tools you can inject here. Since this line will give you the entire log, gather the metrics and do whatever you want to do. Okay, you have the result with you, then you can play with it. Okay, so this is what the main purpose of using sidecar design pattern, to segregate your primary task from the secondary task without touching the code of your primary or without mixing up the things. Okay, so I hope you enjoy this sidecar design pattern. Just do try this particular POC on your system and do let me know in a comment section if you guys have any doubts. Okay, that's all about this particular video, guys. Thanks for watching this video. Meet you soon with a new concept.